My apologies to anyone watching this video because I just remembered to start recording and I'm in problem number 2. So with problem number 2, what we're coming to see is the numbers that make the numerator equal to 0 create the x-intercepts. The numbers that make the denominator equal to 0 are going to create the vertical asymptotes. Now, if you look at this graph, can you see that it looks like there are only 2 vertical asymptotes, a -1 and a +1? If you look at the denominator, you have 3 factors, x squared plus 5, x plus 1, and x minus 1. To solve for what makes the denominator equal to 0, set each individual factor equal to 0. When I try to solve the equation x squared plus 5 equals 0, I end up getting x squared equals -5. When I square root both sides, do you see that we are getting imaginary numbers? If I am getting imaginary numbers, imaginary solutions, what that really means, they're not imaginary, but we call them that. They are solutions that are basically in a different dimension that we are not looking at. So what does that mean to you? It means you don't have any other vertical asymptotes, and you don't need to worry about it at all. Just there are no real solutions, so it will not give me any vertical asymptotes. You can see then with, just realized I wrote that weird, with the other two, and yes, you calculate the y-intercept like normal. Just plug 0 into all the x's and see what number pops out. And then look at the graph and just make sure that it looks like it's doing that same thing. So based on the equation and solving for what makes the denominator 0, I should have only 2 vertical asymptotes, and that's what this graph is showing. And just know that today's lesson is just trying to get you a little bit familiar with what some rational graphs might look like and doing a little bit of a compare-contrast with the equations and their matching graphs. But also, we're ultimately trying to make some conclusions about how to find x-intercepts, y-intercepts, and vertical asymptotes. The y-intercept, if I look at the graph, it looks like it's 3.6-ish. If I go to the equation, I will find the y-intercept if I plug 0 into all of my x's. So 0 plus 6 times 0 minus 3 divided by 0 squared plus 5 multiplied by 0 plus 1 multiplied by 0 minus 1. Altogether, I have 2 negatives. So I'm going to get a positive number. And that number is 18/5. And then 18/5 is 3 3/5. So, oh, wow. I guessed right. So about 3.6 right there is that y-intercept. You can leave your answer to the y-intercept as a fraction. You can write it as a decimal. You can write it as a simplified mixed fraction. It's up to you. Then I want to actually skip over domain a moment and just go to vertical asymptotes. We found out that our vertical asymptotes are -1 and 1, And we can see that by looking at the graph. When we solved for what made the denominator equal to 0, we found that these are the only things that make it equal to 0. That also tells me about my domain. These are the x-coordinates that my domain has to miss, because I cannot plug those numbers into this fraction. I will get a divided by 0. So my domain is -infinity to -1, and then -1 to 1, and then 1 to infinity. All right, next. Take a look at it. If you look at the graph, can you see any x-intercepts looking at the graph? Yes, you can calculate vertical asymptotes and domains without the graph. What I'm trying to do is have you work with an equation and a graph and see the strengths and weaknesses of working with each one. And also kind of getting used to matching them up. So when I look at the graph, it looks like -2 is an x-intercept. I know. And that's where you're getting to, is for your homework to be able to determine these things without the graph. But part of the classwork is you getting used to seeing what these graphs look like. But for the homework, I want you to be able to use the equation and find these things through the equation alone, because you're going to need to do that. Now, if you look at the equation, your x-intercepts are what make the numerator equal to 0. Because if you're going to find x values when y is 0, you're solving this equation. And a fraction will only equal 0 when its numerator is equal to 0. And I can see that it is the only x-intercept. So that means that as I'm looking at these graphs over here, it looks like the x-axis is a horizontal asymptote. And on the left side, it's staying under the graph. On the right side, it's staying above the graph, or the asymptote, I mean. All right, y-intercept. If you look on the graph, it looks like it might be about -3/4. And then if I plug that in directly to the x, I'm getting 0 plus 2 over 0 plus 3 times 0 minus 1. And that's giving me -2/3. So not -3/4, but -2/3. That looks very reasonable with the graph. Then I want to skip over domain and go to vertical asymptotes. Vertical asymptotes are what make the denominator equal 0. The domain is everything except what makes the denominator equal 0. And if you look at setting those individual factors equal to 0, we get -3 and +1. And let's look at the graph. -3, +1, that looks about right. And then the domain. -infinity to -3, -3 to 1, 1 onward. All right, a couple more. And, okay, 3 more. And then you're going to need to write down basically the process of finding these things with just the equation. So, x-intercepts. What makes the numerator equal 0? And the answer is 0. Let's go over to the graph. I see that I have an x-intercept at 0, and it doesn't look like I have any others. Y-intercept is something I get when I plug 0 into all my x's. So I have 4 times 0 over 0 plus 5, 0 plus 2. So I have 0 divided by 10, which is 0. And that matches. The vertical asymptotes are what make the denominator equal to 0. And that would be -5 and -2 are what make each individual factor equal to 0. So those are my vertical asymptotes. And it looks like that does work out with this graph. The domain is then everything except what makes the denominator equal to 0. Okay. X-intercept. What makes the numerator equal to 0? Vertical asymptotes. What makes the denominator equal to 0? Do you see how you can find those two things pretty quickly if you have a factored form? And let's check that on the graph. X-intercept -2, vertical asymptote 4, those check out. The domain is everything except what makes the denominator 0. The y-intercept is what I get when I plug 0 into my x's, so 0 plus 2 divided by 0 minus 4. And -1/2 definitely looks like a y-intercept on the graph. And I think this one is now finally, yes, this is the last one. And then I'll show you what I have with the answers for how to go about finding these things. So in your homework, you're not going to have the graph. You're just going to have this. And you're going to look at the fraction. Whatever makes the numerator equal to 0 is your x-intercept. Whatever makes the denominator equal to 0 will give you your vertical asymptotes. Your y-intercept is found by plugging 0 into the x's, so 0 plus 4. And then in the denominator, 0 minus 6 and 0 minus 3. So I end up getting +4 over 18, which reduces to 2/9. That is a pretty small positive number. And if I look over at the graph, it's fitting. And then the domain is everything that does not make the denominator 0, which in the case of the problems I'm going to be giving you, it's going to be keeping the vertical asymptotes out. It is possible for other situations, but right now you're doing rational functions for the first time, and I'm only taking you so far through them. And then let's double check what we have over here on the graph. Vertical asymptotes 3 and 6 looks good. X-intercept, the only x-intercept, -4. And it looks like it matches up pretty well. Then for explain how to find all those various things, you should write what's going to help you, not necessarily just copy down what I have. If you want to find the x-intercepts, one thing you might want to write down is x-intercepts happen when y is equal to 0, y-intercepts happen when x is equal to 0. If y is equal to 0, then you are dealing with a polynomial divided by a polynomial equaling 0. And hopefully it makes sense to you that the only way for a fraction to equal 0 is when the numerator is equal to 0. So to put it in terms of something that makes sense, if you invite friends over to your house and you promise them cookies and you tell them, I'm going to evenly split all of my cookies with you. And they go, oh, yay, I'll come over. I want cookies. And then they get there and you say, I have no cookies. I didn't lie. You each get the same share of cookies that I have. You get 0. Ha ha, ha ha, ha ha. Okay. So realize that it's when you have 0. Yeah, it's a good way to lose friends. But that's what I mean by think about it, makes sense of the fact that to get 0 out of division, you have to begin with 0. And you can divide it by however many friends you have, but it's soon to become 0. All right. I also want to point out to you when we go to the vertical asymptotes, we have a polynomial divided by a polynomial. Vertical asymptotes are occurring because the function is coming out with numbers that are heading to infinity. Infinity happens when you divide by 0 and you didn't start with 0. If you start with 0 and you divide by 0, it's very questionable what happens. But so this would be an example of you have 5 cookies and no friends. How many cookies do each of your friends get? Do you see how that's it's actually kind of a weird question. You have no one to give cookies to, so how much does each person get if you have 5 cookies? According to that no one, they get kind of an infinite number. That's a weird thing to think about. It's a lot more complicated than just this. Okay. Oh, that's right. I am supposed to go to a meeting in the middle of this class. Oh, dear. Wish I could go back to learning how to count cookies with Cookie Monster. Aw, yeah. Okay, so this will work out okay. Wait, what time is it? Oh, because class is going to be over at 1:45. Ha! That's why things are going to work out okay. We're almost done with our classwork. But those are kind of the two big things that I really want to point out to you are what it means when the numerator is 0, what it means when the denominator is 0. And I'm going to avoid giving you the situation where they are both equal to 0 because that's a different scenario. So your homework then You're not going to be able to see the graphs, but know that if you want to see them, you can download Desmos. And through Desmos, you can put these equations in and see if they match up with the information you're getting, if you want to do that. But what I'm getting at is for you to find this information by just looking at the equations. So with domains, you know, in my day, they didn't make us, it was, your domain is everything except for what makes the denominator 0. When I was in high school, they weren't forcing the interval notation at the high school level. So we would go over to domain and we would just say all real numbers, but x is not allowed to be -4 or 2. What you guys are having to do is write what that means on a number line. And if these two numbers are kept out of the domain, then that's giving you 3 sections. So every time the denominator is 0, I know. I still like it a lot better to just say all real numbers except these. It's kind of tiresome to write the interval notation. Yeah. So every single x that makes the denominator 0, you can basically mark it on a number line, and then with the domain, you're expected to write out from -infinity to -4, but not including that. Then from -4 to 2, but not including 2. And then from 2 to infinity. So you know what, I'll tell you this. I don't have a problem if you want to write your domain this way. It is a completely legitimate way to write it. But what? Oh, I'm not completely sure what gaster? Totally gaster? I don't get it. Okay. Oh, okay. Okay. Faster. I see. Yeah. So I don't have a problem if you want to write the domain that way. Just know when it comes to standardized testing, they expect you to know interval notation. But that gets you going a little bit. And I wish I had that quiz for you because I'd start you on it right now, but I screwed up, much to your satisfaction and joy. So what you can do is, instead of worrying about a quiz right now, you can spend the next 5 minutes working on homework. And for these, know that the purpose of these is for you to match up you can find x-intercepts, you can find vertical asymptotes. Start with those 2 things to see if you can figure out who matches with who. And then I can go over those tomorrow. Oh, nice. If you finish the homework, then there isn't a quiz today because I failed to make it. I started making it. I got distracted. And yeah. Yeah, and then everybody's happy for it. Oh, dear. I guess I'm just going to have to blow that quiz off. And tomorrow, though, you will have a quiz on the equations You'll have a quiz with these equations, solving these equations. I will not give you the hardest problems for your quiz. I would say number 2 isn't too bad. Ha 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 ha. I'll be decent about the problems I put on the quiz. We all forgot about important things. X-intercepts. I don't know. Anyway. Okay, I'm going to stop